Welcome to Pindar Poetry. We hope you learned something new.
You start by verifying hardware and drivers so progress isn't blocked. Run NVIDIA SMI to see the GPU and driver. Once done, install the CUDA toolkit and matching cuDNN that fits those versions. Create and activate a Conda environment immediately to isolate packages. Install pip or Conda packages inside that env. Make sure you pick a Python version supported by your ML frameworks. This prevents dependency conflicts and keeps Jupyter kernels clean and reproducible for the next steps. Now you install the GPU-aware libraries and link your environment to Jupyter. Use Conda or pip to get the GPU build of your framework. For example, Conda install CUDA toolkit with matching versions or pip with the vendor index when needed. Then install Jupyter Lab and ipykernel and register the activated env as a kernel so you can select it in notebooks. Finally, verify from a notebook by importing the library and calling the GPU availability check. This confirms the software stack communicates with the. You finish by running a quick practical test and preparing to debug common failures. Open a notebook, choose the GPU env kernel, and run a small CUDA allocation or brief training step to ensure computations land on the device. Observe timings to confirm acceleration. If something breaks, make sure the kernel matches the environment, check NVIDIA SMI for memory pressure, and confirm CUDA toolkit and driver versions align. One key troubleshooting tip. A driver-CUDA mismatch is the most frequent cause. Update the driver or install a compatible toolkit.
Thanks for watching. Consider subscribing if we helped you.